Good day. This is Terry Holmes and Claire Grant. Today we're here to sponsor the webinar on x86 OpenVMS version 9.0 update. We are delighted to be with you. I will also tell you that there are probably more participants in this particular webinar than any that VSI has hosted in the recent past. So this goes to the interest in the x86 product and project. And we'll give Claire, as our Chief Technology Officer, plenty of time to discuss that with you. So we're delighted that you're here. The agenda for today will be, I will say a few comments about some recent developments at VMS Software, because some of you may not be aware of it. And then we'll turn the time over to Claire for a presentation. We always try to allow a good bit of time during this approximately 1 hour webinar for questions and answers. Those questions can be posted on the chat box, and then we will address them at the end of Claire's presentation. So, without further ado, we will proceed to begin. So, we are delighted to tell you that there has been a lot of activity here at VSI. There's been a lot of things going on the last few months, some of which have to do with the PerfDat and Service Control acquisition that was made from HPE earlier in the year. Some of you may have had a chance to attend the webinar that Thilo Lauer really was the keynote speaker on last month, and that we've got some great reaction from that. Service Control is a product that we acquired along with PerfDat. It's really something that can enhance the availability of potentially business-critical services. We're going to be having more information on that soon in a separate webinar, so look forward to that. We also came out with a new password management component to our operating system. We've come out with several other new components. You can see them listed here on the screen. Some nice updates from Jim Janitos and our engineering and development team. And we're really excited also about the new self-paced online VSI training program that is available today. Of course, the big announcement, which I'm not going to steal from Claire, was First Boot. I'm not going to say anything else about that for now. And then also several new open source products. And you can see them listed there. I'm not going to go through the entire list, but Brett Cameron and the team have really been doing a lot of effort in terms of bringing forth new versions of open source products applicable for OpenVMS. A major business announcement was made in April, which became effective in June 30th, where HPE no longer sells VSI licenses and new support contracts. So that's a major shift affecting VSI in particular, and we're delighted to tell you that the response from customers has been terrific. We've had many inquiries and many activities involving new business possibilities, which is good for all of us as we continue to grow. Of course, one of the major things that's been in the works now for several months and which is looking to become available towards the end of August, possibly in September, is our new TCP/IP stack, which many of you heard of. There are field test kits available today. The latest iteration is available, and soon we'll be introducing version 10.6. But the main speaker for today is Mr. Claire Grant, our Chief Technology Officer. And without further ado, I want to turn the time over to Claire and let him run the show. Claire, please.
Thanks, Terry. Hello, everyone. So, why are we here? I'd like to talk a little bit about the release plan, which is really just a review. You've heard most of that before. And of course, the big topic is First Boot. Why was this important? What was it? And equally important is what it was not. And I hope to say a few words about that. Next up for us is version 9.0. A little bit of a definition of what is there, so you'll get a feel of what will be in it and who gets it. How do we get from where we are now to 9.0, and what is the status of that work? So first, the release plan. the bottom three bullets here you've seen many times before, but let's talk about the top one first. In January, we made available to a selected set of customers a Cross Tools kit, which runs on i64 and we started out with the Bliss, C, and Macro compilers, the linker, and a few associated tools. That was exactly the set of tools that we use to build VMS itself. In May, we had an update to those particular components, and we added the Fortran compiler. And I believe that next week we'll be making another update to what is out there, and we'll be adding the Pascal compiler. This is not a random order here because we knew that people were looking for Fortran as soon as possible. We have a couple other special customers who are looking for Pascal. COBOL and BASIC will follow in due order, and it was just a matter of somebody has to be at the end of the list, but there's no particular problems there. And both of those have been started. So version 9 EAK, very limited to, I'm going to say, between 10 and 15 participants. And that's more a starting point for us to give us a feel for how many people we can actually support. There will be the Cross Tools, again, running on i64, and then you'll be able to execute your applications on the x86 platform. We are at this point promising VirtualBox and KVM, and I'll also tell you that we're working on the HPE DL380. That may or may not be something we say go for it, but we know that people will get the early developers kit and throw it on just anything they can find, and I want to at least have in my back pocket that we want run on at least one piece of real hardware. 9.0 will clearly be less than the complete production system, and we're looking, it's going to be an intersection of what we can do and what people want, and we'll get to that in a second. 9.1 will be available to everybody, and it should include all components of the system, and then a production release later. So no change in the plan here, but this is probably the first time we've presented in public the Cross Tools kit, where it is and where it's going. So first boot. Let's start back at the basics just for a second. Here was the plan. Has been this way since day one. So where are we? If you look at executable images, yes, we have compilers, we have assembler, all of the things in the definition are there. We have a linker, a library, and an image activator. Install is ready to test. We're just not quite at the point where we're ready to test it yet. Analysis tools, SDA and user mode debugger are in the works right now, and we have XDelta image analysis and object analysis, which we've been using ourselves now for months and months. Architecture-specific needs themselves, there are things about booting. There are things about interrupts and exceptions. Exception stuff, I'll get into that in a minute. A couple other things I should probably add to this list, but I will as we get to them. Memory management was probably the biggest task we had for x86. We've done a ton of things. There's still another ton of things to do. Atomic instructions kind of take care of themselves with the compilers. We have not addressed floating point at all yet, and I'll have more to say about that. And in terms of special needs for code and assembler, we've cut it down dramatically from previous ports, and I've got another word about that later. Compiling and linking everything else. I've got some stats on where we are with this, but basically we continue to increase the number of things that we're compiling and linking all the time, in a bit way beyond the things we actually need at this point. And my last item, which is always interesting, there are some special things that happen between calling macro routines in other languages. And I think we have most of that straightened out at this point. I wouldn't be surprised one way or the other if we find any more or not. So that's kind of a recap of where we started. Okay, well, we did it. Why is this such a big deal? Well, it is important for a number of reasons. One of them is it's an identifiable place in the system that people can actually get their hands around. You know, if we said, holy cow, level 4 page tables now work, no one's going to get too excited. But when you describe something like being able to do a directory command, it gives people a feel for, yeah, there's a bunch of stuff that has to work at this point, and lo and behold, here's some output. It's also a great target for the engineers ourselves. It gives us a very, one thing about first boot is it's a very orderly thing. You know, you do A, you do B, you do C, right in an order, and eventually you get to an endpoint, the directory command. So that makes it a nice set of targets for the engineers. It's also a great proof point for the customers. I would hope that when some of you heard that we accomplished first boot, you said to yourself, holy cow, this may work someday. We say the same thing. But when you get to first boot, there are an enormous number of things that are very key to where you ultimately end up that you're doing already. And here are a few of them in this bottom bullet. Compilers and linker creating executable code. Well, you know, how obvious is that? Well, maybe, but there's a ton of work that goes into all of that before we even get to execute anything. There are a number of platform-specific things that have to be done when you move to a new architecture. Many of them are executed very early on in the system coming up. There is also a lot of VAX Macro 32 that's been compiled that you encounter early on in the system. That is usually another adventure. We increased the size of many data structures. And the last item, by default, code is now going to run in 64-bit space. This actually surprised me that we didn't uncover any more problems than we did. So I was very happy about that. Now this list of notables here, you could make a mile long, but these are some of the things that you can identify that are critical, and we've been beyond that now. Do that 100 times, I can see. So what was different about first boot? And the answer is not the code, it's the environment that we ran it in. And I'm going to make a big point of this for a couple of slides here because people often hear me say, well, we have to cheat a little bit for first boot. Well, the cheating is really minimal. We're executing the same code that we're going to in real boot. We just run in a slightly different environment to cut down on the number of things we have to grapple with. So I got two lists here. I'm going to jump back and forth from one to the other. The first thing is all the files that were necessary for first boot, we put in the memory disk file itself. In a real boot, some of these files are out on the system disk and we have to go find them. Number two, all the files that are in the memory disk are what we call execlets. The big thing about that is they all get loaded into memory right during startup. Again, we don't have to go find them. Third thing is we only run in kernel mode, which is not a natural thing to get to do when you're bringing up the system. And in the real boot, you're going to be switching back and forth between modes, and you end up running in user mode pretty soon. By not doing that, it eliminates a bunch of things that we don't have to think about. And the other thing that we do is when we do a system build, we end up with a kit on our development system. For our debugging, we directly net boot that kit into our virtual machine guest and start executing. We don't even have a system disk at all. And we'll get into more of that later. But again, I want to emphasize, we didn't write a bunch of special code to get the first boot. We just confined the environment in which we were running. Now, this is just a picture of what I just said, but I can add a little bit more here. The beginnings of bringing up the system are a fairly well separated set of circumstances. You got the boot manager, sysboot, which is really a standalone program. There's no VMS around it here. It's just sysboot. Then we get into initializing the executive. And then the three boxes on the right, and this is what I'm really talking about on the previous slide. Normally, in what we call sysinit, at the end of it, we create a process, and then we run the startup process. Well, that's not what we want to do right now. Once we get to the DCL prompt, we want to run the directory command. So we kind of manufactured a special environment here, but again, I want to emphasize, there's not different code. We're executing the same code that we do in a real boot. And in the picture on the bottom, there is the magic directory command that we all ran around and clapped our hands at 2:15 in the afternoon on a Tuesday. I'll have a couple of war stories here along the way, a couple of details. One of the things that happens during startup is you invariably run into something that takes forever to debug. And my favorite story on this particular port is it took us almost a month to mount the memory disk as a device. And I'm telling you, 4 people debugging basically nonstop for a month to make this one thing happen. Well, one of the things that happens once you do something repetitively that's really tedious is, I don't want to go look at this and this and this and figure this out. Boy, it would be really nice if we had a running system to do what we normally do. So what we did was, you can see this list here. These are things that are either DCL commands or things that you would do in SDA if you had a running system. So what we did was we created a new debugging command, and we stole the code from all of these things down here and stuffed it into the debugger. So you could do a show pool, or you could do a show trace, just as if you had a running system. This saved enormous amounts of time. And I want to tell you one story about 9 semi-J and C semi-J. Show device and show UCB, which is a data structure. So showing the devices that you have as the system comes up is pretty minimal list. I mean, this is all it really is there. What I've highlighted in red, that device, the DM device, that's the memory disk device. That's the one that is crucial for this little story. So if you take that address and you put it in this other semi-J command, you will get the data structures just as if you were looking at this with SDA, for example. So in our particular case here, we couldn't figure out why we couldn't mount this thing. We were getting a successful return back from the routine that says mounted. Okay, but we still could see that there were things that were wrong. So we said, okay, we're tired of finding these structures, so we created these commands, and that very first long word up there, where it says device characteristics, there's a bit in there that was not set, and that bit says the thing is mounted. Well, we were getting a return from the routine that said it's mounted, but clearly it was not, so what the heck was wrong? And this helped us immensely in getting to the real problem. So things we did along the way to make life easier for ourselves. Okay, that's kind of the story of first boot. What is 9.0 all about? As important as anything is we get feedback from real people doing real work. It's going to be rough around the edges. I mean, that's about the nicest politically correct statement I could come up with. It's not going to be bad, but it's not going to be a polished event either, but that's why it's restricted to a certain number of people who are willing to live in that environment. The content of what is in 9.0 is an intersection between what a selected people need to be productive and what we can produce in a reasonably good time frame. That may limit who the participants are. It may limit the time involved, but we just have to make that trade-off along the way. 9.0 will still be cross tools built on an i64 system. And we are promising that you can do this on VirtualBox and KVM, but I have no doubt that somebody will try some hardware, and we're doing our best to do a little hardware work ourselves along the way. The support for 9.0 will be directly from us, the engineering team, and there will be multiple updates undoubtedly between 9.0 and 9.1. This could probably be a little controversial. It was controversial as whether I included in this presentation or not. My former employer was big on is and is not lists. Well, this is kind of a maybe not list at this point, but we're getting there. And the real statement here is, it's not that these things won't work or they might not be present in the system. I'm just trying to eliminate as many things as I possibly can so we just don't have to think about them and test them. So I have a list here: Deck Windows Server, DECnet, et cetera, et cetera. And now clusters may jump out at you there as why the heck not, and it may well be working. I don't doubt that it probably will. But I can tell you that of the customers that we sent the questionnaire to who wanted to participate in 9.0, not a single one of them said, I need clusters. So that's why it's on this list, because if somebody who I really care about really needs it, that will be another story. But right now, that's why it's on the list. I'd like to get down to the last two bullets. Support for privileged applications. Now, I'm not saying here that you can't link /system. However, if you've got a device driver or you directly manipulate page tables, you need to talk to us because things have changed. How much we want to support that or how much documentation we'll have ready for 9.0 is kind of the question. VAX floating point will definitely not be in any of the cross compilers. Everything for 9.0 is going to be IEEE. 9.1 native compilers will have VAX floating point except for C++. I could do an entire hour's worth on why this is true. And right now, and there's no decision's been made, but it's very possible that there won't be any VAX floating point support in C++ and x86. If it's absolutely necessary, it's going to be a gigantic project for us, and we're going to have to make a determination at some time whether or not to do it. So that's the current maybe not list. I like the proof points that we had up there on the website for first boot, so I decided to do it again. And this is a little different because, as I said, first boot is a very serialized set of events. Getting to 9.0 is not a serialized set of events. You've got a ton of things here that are going to happen independently, and this could be, 50 items on this list. I just happened to pick a few because I think each one represents something significant underneath it in the operating system that needs to be working. And I've given my my T-shirt exercise of small, medium, large, or extra large. Small, it's easy, there's not much to do. Extra large, it's hard, and there's a lot to do. And medium and large in the middle is just whatever it feels right to us at the moment. So I'd like to say a little bit about these. We've gone from first boot, well, we've gone to something which we call real boot. And that really is get rid of these special execulists, get rid of this special environment they ran in, and do the real thing and get to the directory command. I've added one more thing in here, which isn't absolutely necessary to get to the directory command, but I want to make it so we do it for what I call real boot. And I want to make the switch from reading from everything in the memory disk to the real system disk. So when those three things happen, I will declare that we made real boot. As I said, KVM VirtualBox, we need to definitely have those ready. We don't do a real installation like a customer will do right now, but that is in the works. I put crash dump and SDA in here together. They kind of go together, and trust me, we cannot wait to get to the point where we can have dumps to look at. Conversational boot we need for various reasons, and everybody else will too. Creating user accounts, dismounting disks, running batch jobs, having TCP/IP, having backup, user mode debugger, and threaded applications are always interesting. And as I said, this list could be a mile long, but I think these all represent something significant to get to. Okay, so that's what first boot was, and that's what we think 9.0 is going to be, how do we get there? Now, if you're familiar with presentations that I make or anything I publish on various news groups, you'll know I love the loaded image list. The loaded image list is if you are human, you go to a technician and they take a sample of blood, and you go to the doctor and they tell you that your entire life history from a vial of blood. Well, this is kind of like the blood test on VMS as it comes up. So I've given you a very abbreviated list here. I've only given you the image names. There's a ton of information that comes out with these things, and that's what we really work on. But the list itself can be interesting. And I did this, 2 days ago from a snapshot from my screen. If you look at the left-hand list, I've had some things highlighted in red. In particular, let's look at the ones that are, 58, 5A, 5C, 5E. We now have our virtual machine guest VMS on the network. However, we can't run any of the tools yet that you normally use to drive it. Now, I'm not talking about TCP/IP here. I'm just talking about the device driver itself. So these three things that say LAN, they usually have command interfaces of various sorts, but we can't do that right now. So what we've done is we've manipulated these things slightly so that you can fire commands at this thing from another system. And so you can be on a development cluster and direct commands at your virtual machine and cause network traffic. So I'm very happy to say that just in the last couple of weeks, we went from nowhere to being able to generate tons of network traffic with the driver. Very big step forward. Down at the bottom, there's some more things in red. Two categories there actually intermingled. There's a bunch of things that say $debug. These are tools that we developed for ourselves that help us in debugging. Another case where we needed to make things work early, so we made sure these things got in there and can help us. And then there are the three things in 46, 48, 4A, though sysinit, login out directory. Those are the special execlets that we loaded up until yesterday's build. So those won't appear anymore because we don't need them anymore. Middle column, pretty standard stuff, nothing special in there. I wanted to highlight one thing over here on the right, and that is system primitives. This is one of the low-level pieces of the operating system, and it contains really two sets of routines, I'll call them. One are specific to the platform, and two routines that are used by almost everything else you see on this list. Now, the _2 is interesting because in your system in the future on x86, you can see anything after that underscore from a 0, 2, 3, 4, 6, 7, and maybe more in the future, and I want to describe a little bit about that, what that is. The first thing is we will load code to be executed depending on the features available in your processor. Because one of the things we do very early on is we poke the processor and say, who are you and what can you do? Well, we will base some of the things that we do execution-wise on the capabilities presented to us by the processor. Another thing that depends on what we load is this. And what we've done here is, depending on the processor, it is vulnerable to the MDS vulnerabilities. We will load the appropriate code that will do the mitigation for that. And what you see in the middle here in bolding, right after the banner, it's going to tell you if MDS mitigation is active on your system. So there are kind of three stories here. Either your CPU is not vulnerable and we're not going to do anything. If it is vulnerable and we're doing mitigation, we'll tell you. If it's vulnerable and we're not doing mitigation, we'll tell you that too. So my two notes down at the bottom are, there's going to be a method for disabling this. Somebody can overtly say, I don't care, and they can turn it off. And then we will publish some performance numbers when we get to the point that says, here's what we roughly think the performance hit will be if you turn this on. Okay, so 9.0 is real boot plus much, much more. So a few things I've noted here. If you look at our project work at the moment, there are 344 individual developer tasks identified to get to 9.0. We get about 20% of them done. One of the things we've done already is eliminate the, if this is first boot, do something special. And this is in all languages, header files as well. And I think there were 22 places in the system where we had this conditional in there. I think we've eliminated all but 3, and that's just because we haven't got to it yet. So for all intents and purposes, we're done with anything that we said if it's first boot. Real boot, so I mentioned before, load all the images. We've done image activating just to get to first boot. We're in the midst of running down a real user process and switching from the memory disk to the system disk. So those 4 items are either done or in the works. Memory management, we have lots more work to do because we've only run in kernel mode. And now when you add user mode and the 2 middle modes, this makes memory management significantly more complicated. We need to get a real customer usable installation process in place, and that is in the works. Exception handling, we have the basics there now. Handling of the individual items is in the works. And as developers, we all have our favorite little test programs that we know kind of poke at the places in the system that can be weak when you do a port like this. I put this running layered products on there, needed participants. I'm hoping that's 0, but if somebody who really wanted to participate needed something, we'd probably figure out how to do it. And then we've got the user environment test program as part of our build and ships with the system. We'd like that to be running. And then our qual and test group has tons and tons and tons of regression tests, IOHammer. You've probably heard of half of them, but we would like to get as much of that in place and running as possible. So we have a long ways to go, but I think we've got a pretty good layout in front of us to get there. So where are we with all of this? So here's the current status of the proof points of a few slides ago. Done with no special executives. We can get to the directory command and booting from the system disk. I have a 0 up there, but that's probably a little unfair. But we haven't started debugging much of it at all yet. KVM and VirtualBox, our equivalent. This is a big deal. We did almost all of our first boot debugging on VirtualBox, and I mean all, 8 of us that were doing of this. We just kind of put KVM in the background for a while. So a couple of weeks ago, after we got the first boot, I went back to KVM, and we got nowhere, and I mean literally nowhere. So we knew we had to fix the timing mechanism so our interval timer would work. That was fairly easy because we knew it was coming. But then we got a big surprise, and we couldn't configure a darn device. Well, one of our developers who is looking at ACPI, and we were having this problem, happened to read on the website where you get ACPI, their comment section, and lo and behold, there was a description there of a change that was made just a while ago in one of the modules. It said, on certain platforms, you will end up in an infinite loop. And voila, that was us. So with a couple lines of code change, we booted on KVM, and we went all the way from device configuration to doing the directory command with nothing else in the way. So I was very happy with that. So I want to keep KVM and VirtualBox on an equal footing all the way. And we'll do the best we can with the DL380 at the same time. Installation, we're a long ways into having the real installation process in place. 75, maybe even a little low. Crash dumps in SDA. The crash dump part, we're getting close there. We need to improve our environment a little bit, and SDA has a lot of work to do, but it is in progress. Conversational boot, that 90, I'm told, should be 100 as of yesterday. User accounts, all builds today, ready to test. Anything up here that says ready to test means it compiles and links right now, and we're just ready to have the environment to test it in. I have a TCP up there as 0. That might be a little unfair, but we really haven't started much because the team that works on it has been busy getting out the current product. Backup, not a lot of work today. In fact, a lot of what needed to change for backup has already been exercised in the beginnings of the installation procedure. User mode debugger, big job, big job. Difficult and a ton of work to do, but in progress. And threaded applications, we think most of what the underpinnings in the operating system need to do are there, but there's 2 levels above that I have no doubt that will give us a headache for a while. Okay, we can't talk about x86 without seeing the compiler picture. The picture itself hasn't changed other than the colors. So what I try to do here is, if it's in green, it is either completely working, it has been for a long while, or it's to the point where there's not much we can do other than get some feedback from customers. So obviously C, Bliss, and Macro, we've been executing for months and months, and the converter, LLVM itself, librarian, and linker, we've been using those for 2 years. So that's as done as it can get without some customer help. Basic COBOL, C++, and Ada, it's probably a little unfair to have them all the same color. I could probably make basic COBOL and C++, pinkish at this point. They're off the ground, they're started, and they're on the way. And Ada is still fire engine red, and we have lots of discussions going on at the moment, and we know we have to come up with a solution, but we don't have it yet. That's about as fair as I can get with that. But as you can see, here's the big picture. Started with it years ago, and we pretty much executed to it. One more thing about getting compilers to x86. LLVM, the back-end code generator that we're using, is based on a 2014 release, which is kind of way back in the beginning when we started. We know we have to update from that at some point, but it's not easy. I mean, we have the classic chicken and egg problem here. Well, it's almost like we have 2 chickens and 2 eggs. The C++ compiler that we have on Itanium is not able to handle all of the things that LLVM and Clang require. So, under the plan, the first bullet, we are taking the newer version of LLVM onto our Linux system, adding the VMS-specific changes that we made to that, compiling it on the Linux system to get those objects, bringing that over to our i64 system, and cross-compiling it with our linker. Now, the thing that makes that all work is the fact that we shifted from our private formats to ELF when we ported to Itanium. Probably the biggest and most difficult decision we had when we moved to Itanium, but boy, has it been worth it. And with C++, there's a ton of libraries, and we have to get those, move them over, do it with our cross-linker, and build everything for x86. So there are 2 or 3 threads of work in there, but this has already begun, and our plan to do it this way seems to be panning out. And just for the record, there will never be a cross-compiler on Itanium for C++. We decided that was just way too much work to make it worth it. And before we get to 9.1 and 9.2, we will clearly update to newer versions of LLVM once we've proven that this all works for us. Okay, that's my compiler story. We'll end with a little trivia here. When we build for Itanium today, we build 887 images. Now, this does not include compilers, TCP/IP, the layered products, and a whole bunch of other stuff. This is just the stuff that we build in the main operating system build. As of yesterday or the night before, the current x86 build is 654 images. And just as a side note, just over a year ago, that number was 347. So in the course of about the last year, we now build 300 more images than we did over 12 months ago. Also, I'll note that given the Itanium build, it's not that we need those exact 887 images for x86, but it gives you a nice ballpark to think about. It's roughly in there somewhere. And the difference between the 887 and the 654, 233, we don't need all of those for 9.0. My count is, from what we have today, we need 122 more for 9.0, which is a pretty comfortable number, I'll have to say, given where we are right now. How much code has changed? That's a question everybody likes to ask, and there's no real answer. So I took a stab at a couple things here. There have been 2,500, roughly, individual module replacements for x86. A module replacement is you reserve a piece of code and you check it back in. Is that number exactly 2,500? No, but I'll bet money that it's bigger than 2,000 and less than 3,000. So what constitutes a replacement for new code? Any new module that you create, and of course we have created some new ones, either because they were required for x86 or we rewrote some macro 32 code into C, for example. Anytime you revise a source module as a replacement, and that doesn't matter whether it's one line, one routine, 100 lines, you name it, a reservation and a replacement is a change. Also included in this are all the build procedures to build this, 800 image monster. They all have to be looked at and updated for a new platform. And my fourth bullet here, the verifying, updating of conditionals. This is a pretty big event and fairly special. Before we started on x86, you do a monster set of searches on our code, the entire code base, and you find all the places that have conditional statements in them. Whether it's Bliss, C, macro, DCL, you know it. If it says if alpha this and if Itanium this or whatever, every single one of those has to be looked at. And what we do is we assign them to people, and once you've looked at it and said, yep, this is good, or I changed it and it's now good, you have to put a comment like I have out here on the right. Because someday we're going to run this set of procedures again, and I want to see that every single one of these conditionals has been looked at by somebody. And that's how we do this. The first build for 9.0 was 2.5 years ago. I imagine it was pretty minimal then, but come a long way. But we've been actually building 9.0 for x86 for over 2 years now, 2.5 years. I don't know why I picked this in particular, but there are 26 modules right now written in native assembler. That feels like a pretty small number for me. I didn't go back to look what we do on Itanium, but I'll bet anything that it's at least twice that big. So I was pretty happy about this because the more you can limit native assembler, the better off you are. And my last item up here, 1180, our test group tests various releases on various platforms to the tune of somewhere between 4,000 and 5,000 hours a week. So last week I happened to look at what happened with version 9 on Itanium, 1186. Okay, well somebody might say, who cares? Well, just as my example out here in the parentheses, we have written or rewritten a lot of code in the memory management space. 30% of that, at least reasonable estimate, I think, is also common code. And I just don't mean in the same modules, I mean common executing code. So I put this last bullet up there to say that while we're doing lots of things that we haven't gotten to yet to actually debug, a lot of it gets debugged on Itanium because we're doing the exact same set of routines. I like throwing up a few statistics now and then, but this kind of gives you an idea of the magnitude of where we are, where we've been, and where we have to get to. As I said, of those 344 individual tasks identified, yeah, that number will go down tomorrow, but it could go up next week as we find more things. So, it's not like it's a hard and fast number, but it gives everybody a good measure of where we are. So we feel pretty good about first boot, and I think we feel really good about where we've come in the short time since first boot. I think that is a good omen for the future. And I believe that's the end of the trivia and end of what I have to say.
Well, thank you very much, Claire. We all, I know I speak for everyone, we appreciate you taking the time out of your busy day. And as you said, x86 is a absolutely strategically key product for VMS software. And you and your team have been working on this for quite some time, and thank you for giving us the update on first boot and version 9.0 and giving us a path so we can see the future.
We aim to please.
Absolutely. So that's terrific. I think there's a couple of other things just to comment on. First of all, this webinar is being recorded, and the recording and the slides will be available on the VMS software website in probably the next 24 or 48 business hours. But I think also another important point that we'd like to congratulate Claire on. Next week is the 5th anniversary of VMS software formation and our founding, thanks to our parent company, TerraCloud Corporation. So Claire was one of the original employees, so congratulations on your 5th anniversary, Claire.
Thank you.
And we hope that there's many more anniversaries, because there's a lot more work on x86 to come. So having said that, we'd like to open it up for questions, and so please go ahead and address anything you like. In fact, we've got some questions coming in now. So yeah. So let's see. This is from Tony. Will there be any DECnet support in V9.0 at all, or is there a DECnet version or phase 6, which will be question mark? Will it be included in later versions?
Well, first of all, once beyond 9.0, yes, it will be DECnet, just like you always know it. What I also know is from the people who answered the questionnaire about 9.0, none of them said they absolutely needed DECnet for 9.0 testing. So could it be in there? Yes, but I'm going to say for 9.0, given the responses that I have so far, we will come up with a sufficient number of customers that it probably won't be there and they won't care. But yes, DECnet will be in the future.
Thanks, Claire. Another question coming in, will migration clustering from VAX to x86 be available?
Unknown. It's one of those questions where, will it work? Probably. Do we want to support it? How many options are there that we could possibly support? I'd like to say that you should be able to drop an x86 system into your current cluster, but if you have VAX, Alpha, and Titanium, you're already doing something that isn't officially supported. So available and supported are two different issues here, and we'll just have to work out what we need to along the way.
Yeah, and part of that's probably a business decision along the way as well.
There are a lot of things that flow into that aren't technical.
But that's an excellent question. Thank you, Stanley.
But if you're in an Alpha and Titanium system cluster right now, the answer is yes, but the one caveat is you've got to be running a VSI version of VMS on everything in the cluster, period. There are just too many things we can't handle to deal with if you're running an HP software version in a cluster and add x86 to it. It just limits us way too much.
Another question, a statement and then a question. Looks like all the extremely hard work is paying off. Thank you for the comment, Nick. Is the x86 production release V9.2 still slated for 2020, or does it look like it might now be 2021? Well, I think
2021.
Yeah, 2021 is a simple answer.
And although I will confess to, I haven't looked yet. I think that a new version of the roadmap went up within the last couple of days, and
yes,
it should reflect that.
It has. The new roadmap is up on the VMS software website.
Mm-hmm.
Another question, what are the expected dates for V9.0 and V9.1? You want to just, again, the roadmap, but go ahead.
Again, the easiest way to look at this right now, and I believe this is what the roadmap is going to say, is End of this year for 9.0, end of next year for 9.1. That's just a nice round ballpark to think about.
Let's see. Can you please clear this point? The cluster will be removed or not? Maybe you should address the entire roadmap for clusters.
First of all, clusters will never be removed. The question is if the question is about 9.0 itself, I only have it on my maybe not list because no one who we're really looking at for 9.0 claims they need it. It may well work, and we may just say, okay, there it is if you want it. But no, nothing's going to be removed. And it will clearly be there for 9.1 and 9.2.
Yeah, keep in mind that Claire has mainly addressed version 9.0, which is the early adopter kit. So a lot more, as he said, a lot more work, a lot more components will be going into version 9.1, which is really the version that will be available to all customers and all partners to kick the tires on and do some initial testing. And we, again, as you indicated clearly, we want your feedback when we get to not just 9.0, but 9.1, and then 9.2 is the production version.
Let me say another word about how we got to 9.0 and what's in it. Way back when, and I can't remember when, Terry sent out a message to a couple hundred of our customers and some other selected people and said, here is what we think 9.0 will be like. Do you think you would be a participant? And we got back, I think it's what, 3 or 4 dozen, 35-ish, 40, somewhere in there.
40.
So the people who responded knew well what 9.0 was going to be like. And then I asked them some specific questions about clusters and DECnet and other things. So we have a pretty good idea of what people are expecting, and we're trying to do the best we can to meet the needs of a set of people. But if there's anything that a whole set of people don't want and I don't have to think about, I don't want to.
So, Claire, that begs the question, if someone who's, for example, listening today and they weren't aware that there was a questionnaire, can they go ahead and write to us? And
send us mail and we'll send you the questionnaire.
Yep. Okay. So it's still possible to get on version 9.0 as we move along? Yep. Okay, great.
Certainly.
Okay, good. Will data trees be available, and will the compiler's basic COBOL include support for record definitions in Oracle CDD?
Well, available someday. I assume the answer is yes. 9.0, no.
Okay. Will there be a runtime image translator like VEST or AEST?
We did some beginning work on that, but I will confess that right now we do not have a solid plan to complete it. So as of right now, I'd have to say no. And I'll add one thing here is, even if we continue what we started, it's only going to be for alpha images and not Itanium.
Okay. I think it's also important to note for the participants of the webinar that over the last year and a half in particular, we've added additional resources to improve the work that's being done just overall in VSI engineering, but specifically for the x86 project. So I know that yourself, Jim Janitos, I've personally witnessed probably the last 6 months a lot of interviewing going on and additional people being added. So that's an important point to bring out to the participants today, that we are adding resources on an ongoing basis. And part of that is because of I'll say it, the success from the business side that we are really starting to have, and we appreciate that business that we are receiving from everyone who's listening today and those who don't have a chance to listen today. So,
but if you know of 100 people who will walk in tomorrow and do some work, I'll take them.
Okay, let's go back to let's see. Is there a conversation with Oracle for Tuxedo on V9 x86?
I can't answer the Tuxedo question, but I can tell you that we've been talking to Oracle since day one, actually before day one. So we've been in constant contact with the Oracle engineers since our beginning.
And specific to x86, I think, correct me if I'm wrong, Claire, but they've already provided us feedback on cross tools and some other things. Why don't you talk about that for a moment?
Oracle is one of the users of the cross tools, probably the biggest, and we've gotten some excellent feedback from them. So I know that they're plugging away at the technical details as well.
Yeah. Okay. Good. Let's see, any solution in view to replace Deck Scheduler?
Out of my realm. I don't know.
We'll have to get back to you on that one, Mark.
Mark.
Yeah. Okay, we got it. Deck Scheduler. Let's see. Any other questions? Claire, are there other things that you see happening, whether it's in the short term, in terms of, I made a comment on resources and things like that. Anything else that you may see in regards to
Well, since
your
no
team?
one asked the VMware question, why don't you answer it?
Yeah, okay. When are we going to be available on, when is VMware and x86 going to come together? And I can probably answer that as well, but it's clearly on our radar scope.
Well, and the difference between now and a year ago is we're having a different type of conversation than we did a year ago. I mean, and I think a lot of this is we need some help from our customers.
Yeah.
Because we by ourselves cannot make the business case that's going to be good enough for VMware. We've got to have some heavy hitters on our side to say, please make VMS a supported guest because we, XYZ customer, need it. And by the way, just for kicks, a couple of months ago, a couple of us downloaded the free version that you can put on your Mac of VMware that you get a 30-day license for, and lo and behold, we got a long way. So, you know, would it be a technical challenge? Yeah, every single platform is different. Every VMS use of being a guest is different. They're all different. However, given what I saw and given where we are now, yeah, I don't see why it couldn't work technically, but that's the lesser of the two questions.
Yeah, Claire is absolutely right. The business case is very important here. As he said, we have had a couple of customers specifically have a discussion with VMware and if they're going to support our x86 product, and that has caught the attention of VMware.
As I said, the conversation is no longer technical. It's at the right level.
Right. So we are having those conversations, but certainly if you are today a VMware user or thinking about it or planning on using VMware in the future, please reach out to those folks and tell them that you have an OpenVMS environment, that you want to make sure that the x86 product that they support it, and that would really help our business case a lot. So this is a team effort here between all of us.
I want to tell a little bit of a story here. Back when VSI first started, and just 2 months after it started, I was over in Germany at a big conference over there where we had a bunch of users. Some of you may have been there. And after I got done with my presentation, the very first person who stood up, I'll never remember this, stood up and said, I run my entire operation on VMware except for VMS. It's sitting over on the corner here with this ridiculously high-priced piece of hardware. Please become like everybody else and run on VMware. And I've heard that same story multiple times over the last 4 years. The message is, don't be different. Yeah, I mean, that's the bottom line.
Yep. So VMware is very important to us. Questions raised about Hyper-V. We are not as far along in our discussions with Hyper-V, but Claire, I can tell by the look on your face you want to make a comment.
I'm semi-smiling here because of people we know at Microsoft, and I've had discussions with not the high-level people, but with people who are there that we know. They seem to think that Microsoft will be much more amenable to this than VMware is. So while it's not as high on our list, it's certainly on our radar. And I haven't tried it myself, but I know someone who's about to. No names.
Okay, here's another question from Martin. Any plans to support Synergy DBL language?
Out of my realm, I guess, but we should take that back to others.
Okay. Question about the timing of version 9.2. As we mentioned, It is in 2021. Right now, our roadmap is showing probably later in Q2, kind of the middle of the year type of thing.
At least.
Yeah, that's where it's at today.
The big thing between 9.1 and 9.2 is not going to be capabilities. It's going to be increasing the quality and, in particular, doing some serious performance work.
I see there's a question about, can we provide a contact point for VMware? The answer is yes. We won't do it in the webinar, but I see the note from Keith, and we'll look to send you some information on that. So thank you for asking. I appreciate the support. ACMS?
It's hard for us to talk about the applications at the moment, but it's just so important in so many environments that right now it's hard to believe that we can't exist without it. I mean, on the one hand, I'll be perfectly truthful here. Some of these older applications, we wish we didn't have to support, and people will move to newer environments where there are newer solutions, but we just know how embedded some of these things are with current customers. And on the one hand, it's a monster. It's hard to support. It's even hard to build, to tell you the truth. However, it's so important. How could we not do it? I mean, that's the way you have to think about it right now.
There's a question about the version 9.0 and the questionnaire. If you send your, if you're interested in completing a questionnaire, send it to the info@vmssoftware.com, and you'll get a response. You'll get the questionnaire, and then that goes into Claire and his team for evaluation. And again, even if you don't get an answer back right away, maybe down the road in a few months, it may be more of a better match. So you may get a response back then.
I mean, eventually I will get your mail and you'll get an answer.
Yeah. Is the installation procedure being worked on just for version 9.0? Okay.
Yes.
All right.
We're probably 90% done.
Okay. Good.
The big thing about the installation is, as I said, in our debugging, we don't actually ever do an installation. We just net boot the thing into memory and start running. But the installation process itself, in terms of having a real kit, installing it on a target system disk, that's being debugged right now.
Other questions? I know we've run over by a couple of minutes, but that's okay.
No problem.
Well, it looks like we're all set. So again, we want to thank all of you who have participated in today's webinars. We thank you for your questions. We obviously thank you for your interest in what we're doing here at VSI. We know it's of great importance to all of us. And again, we want to thank you for your interest. You buoyed us up for the last 5 years, and we're poised, certainly for the next 5 years, to really take some great leaps forward. So thank you for your participation. Claire, thank you for taking the time out to give us all an update on where x86 stands. There'll be future updates from Claire, I'm sure, because we have a lot to communicate.
I'm good at screenshots.
So, again, we want to thank you for your time. Have a great rest of your day wherever you are in the world, and we'll speak to you soon and look forward to the next webinar. Take care. Bye-bye.